actual values somewhere in your database so that we don't have to recompute that again and again. And that is essentially where your materialized views come in. So instead of a value that is queried again and again, we have a view that essentially is stored in the database with all the values, and then we can just read that values using a select statement, right? So that is the difference between a simple view and a materialized view. In some sense, a materialized view is just a table or a temporary table, not actually a temporary table, but an automated table that is maintained for you. Okay. Okay. So Um, so as I said, materialized views actually create a new table for you. Queries on those materialized views can give you results without actually requiring a recomputation of all of the values that the view would do. And materialized views depends, so optimization over materialized views depends upon what you're doing. So if it's a large enough materialized view, again, optimization might be tricky, but that is the same case if we are using simple views as well, right? So we will talk about indexes later, which allow us to, indexes would basically be allowing us to make sure that even if it is a table, getting data and accessing those values would be a lot faster compared to a traditional database access using select statements and whatever. But essentially, it is a table, right? Anything that a table can do, this can do. The only difference is, so imagine the scenario that if it is a separate table, for example, take the branch summary table, right? So the account summary table that we were talking about. So branch name, total amount of balance, and the total loan amount. So in that particular situation, let's say that we add another branch or we add another account, right? Or we make some changes to an existing balance. At that point, it might be necessary, it is going to be necessary to update your materialized view as well, right? So we might basically, as I said, that need to recompute the contents of the materialized view. So these things would be required to update the current summary table or whatever table that you're maintaining using a materialized view. And these are called view maintenance, right? So if a view is, if a materialized view is basically as it is, the summary or some information from another table, if any changes are made to that table, we need to make sure that that particular table gets updated as well. Okay. So now the thing is, some databases, so as you can see that materialized views are quite a powerful concept that has the same benefits of using a view, where you can provide access to certain users who need that information without actually providing access to your entire database. You just provide access to the things that they need. And it sort of becomes powerful because it is also a table that basically stores the values in the database itself, that does not require recomputation of all of the values that you have. So that is a very powerful concept, but many database vendors do not actually support the materialized views idea. So most definitely MySQL does not support materialized views. Oracle does, but MySQL does not. So MySQL basically supports all the features for a materialized view, but they do not actually support a materialized view explicitly. So for homework 4, I believe, yes, for homework 4, we have a lot of questions that allow you to implement your own materialized view, basically maintain your own table and write queries that would update your materialized view and maintain your view accordingly, right? So it will be a fun one. Okay. So you would be basically be writing your own code in terms of triggers that would follow whenever a change is made. You would change the materialized view as well to get the new set of updated values. A database that support materialized views will perform this view maintenance automatically. It is much simpler in the sense that you do not need to create a bunch of triggers to update your view, but for MySQL, we do need to have a bunch of triggers to update that, right? Okay. Any questions so far? Okay. Um, okay. So whenever we are talking about view maintenance, another thing that we need to keep in mind is, so yes, we are going to maintain our view. We are going to write a trigger that updates an entire materialized view. So whenever a change is made, do we change the entire table or do we make incremental maintenance to that table, right? So we just make sure that any changes that are made, so for example, for an insert trigger, any changes that are made, we only do a row-wise update of those rows in the view and not actually change the entire table every time. So that is basically called an incremental view maintenance compared to recomputing your entire view from scratch every time any change is made. So we can assume that we can sort of write a trigger like this, which would basically be just a view where we delete the existing materialized view and recompute the entire thing and then save it back again. That is obviously expensive, but we would really want to do something like incremental view maintenance that updates the table as we make changes to the original Oracle table, right? I mean, original table. Okay. Again, yeah, DBs with materialized views will do this for you, but MySQL will not. Okay, so that was materialized views. You will have a lot of experience playing around with materialized views in homework 4, as I said. The next thing that we are going to talk about today is basically security details about your database. So mainly whenever we talk about security in terms of our database or in any system actually, we talk about two different things. One is authentication. That basically means that you give a username, you give a password, and the database knows that you are who you say you are, right? Basically, you get a username, you get a password, and that is how the database or your system or anything would authenticate you. The other one would be authorization. That is the amount of privilege that you would have in order to make changes to the database. So am I allowed to do the things that I want to do? So a root user in Linux would be able to delete any file. However, just a view or a guest user in Windows will not be able to create a new file or look at certain files in C drive, things like that, right? So those are the two main things that we need to understand when we talk about security, that is authentication and authorization. Okay. So SQL databases, as with other things, perform authentication using their own secure connections. Most databases already have SSL connections inbuilt with them, so they can actually make sure. You can also think about security authentication systems such as LDAP or what was the other one? MDA. Okay, anyhow. So you can, most database systems actually provide you secure connections so that you can connect to a database remotely without actually having your password being visible in a text format across the internet, right? So they do provide you secure connections. Um, Yes. No, ODBC would be the connector. I think you are, yes, ODB. So notice the difference between the connector and the authorization and authentication part. Authorization and authentication would be how am I sending the password and is it sent securely, and am I able to make sure that this user exists or not? ODBC, Python connector, and those sort of things are essentially just a library that allow us to connect to a database. it has nothing to do with what the security system for that database is, right? It makes sense. So I can basically have a database that does not have any password check at all. So that would be a part of the authentication protocol of that database. Nothing to do with the ODBC or the Python connector. Does it make sense to everyone as well? Because we know that we do provide usernames and passwords to the database using the Python connector, but essentially that. Okay, coming back. SQL provides authorization mechanisms as well. So different operations can have different privilege levels. Users can be granted privileges to perform necessary operations, and privileges can also be revoked for in order to limit certain abilities to certain users, right? Most fundamental set of privileges that are provided to a user is mainly over select privileges, insert, update, and delete privileges. You can either allow or disallow a user to perform a specified action or not. So you can even allow a user to perform certain operations on certain tables as well. So you can say that for the account table, I'm going to allow the user to insert something to it. I'm not going to allow insert operations for this user for any other table except the account table. So things like that. So yeah, essentially the syntax for this is grant whatever you are allowing. So select on account to banker. Right? So here banker would be your user or your user group. So whenever you create a user, you would then be able to create a group of that user as well, or it also applies to individual users as well. And then using this query, banker is then allowed to issue queries against the account relation. That makes sense because we do not want a banker or a teller to be able to insert or update details in your or delete entries in your table as well, right? We want him to be able to select data to it, select data from it, or maybe update it, but never actually delete the data from the table. Okay. So we can also grant multiple privileges to multiple users as well. So we can say that, you know what, so grant select and update on account to banker and manager. So banker and manager both are able to select from a database from the table account, update the table account, but only grant insert and delete to the manager user, nobody else, right? So a banker is able to select and update, but only a manager is able to insert and delete as well. Okay. So we can also specify each table individually. We can also provide privileges to the public. It will make more sense in a second, but give me a sec. So we can say that grant select on promotions to public, right? So that means that on the promotions table, grant the select operation to public. And this does not mean that we are providing access to select to the entirety of the universe, right? These are basically users that have authenticated to come inside the database. They know the correct username and password to log into the database. Those are the public. So basically everyone who is logged in will be able to perform select operations on the promotions table, right? Not in general anyone. We still need a username and password. Okay, we can also grant all privileges to all accounts. So for example, you can have an admin lackey, right? So you are the admin of a particular database. You have an admin lackey